So we are done with our activity. So based on our previous activity, the topic for today is all about Archimedes principle. It is all about Archimedes principle. So but first, let me introduce myself. So I am teacher Mariden P. Katampongan, your science teacher for today. So nice meeting you all. I hope you enjoy our discussion later and participate doing our activity. So, our topic is all about Archimedes principle. But first, let us all know kung sino nga ba ang isang tao sa likod ng principle na ito. So, excited na ba kayong malaman kung sino? So, proceed na tayo sa ating next slide. So, who is Archimedes? So, Archimedes is born on 287 BC and died on 212 BC. Preeminent, he is a Greek mathematician and inventor who wrote important works on plane and solid geometry, arithmetic, and mechanics. So, Archimedes is a Greek mathematician and one of a son of Phidias. Phidias is a greatest Greek astronomer also. So, nasa lahi na talaga nila na mag-contribute sa science. So, Archimedes is well known for his invention and scientific discoveries. One of these is the Archimedes principle. So, he was born on 287 BC in Syracuse in island of Sicily and died at 212 BC at the age of 75. So, legend says that Archimedes discovered the principle of displacement while stepping into the full bath. He realized that the water run over equaled in the volume the submerged part of his body. So, through further experiment, he deduced above mentioned principle. Archimedes saw the water in his bathtub rising as he got in, and that he concluded his principle. So he is shouting Eureka. So Eureka is not a name. So in Greek, it is translated in English as I have found it. So nalaman na niya na yung principle of buoyancy. So next. So upthrust and buoyant force. So what is buoyant force? So have you ever dropped your swimming goggles in the deepest part of the pool? So and tried to swim to get your goggles back? So it is very frustrating because water tries to push up. The water push back up to the surface as you swimming downward. So the name of this upward force is called buoyance force or buoyancy. So the keyword in this principle is upthrust or paglutang or the upward force, which refers to the force acting upward to reduce the actual weight of the object when it is under the water. So, dun nga sa activity natin, di ba, meron tayo dong dalandan na lumutang, yung may balat, and then, yung dalandan na walang balat is nag-sink. So, ibig sabihin, nagkaroon ng buoyant force. So, for example, we have an example here. So, for example, a metal block with a volume of 100 centimeter cube is deep in water. So, it displaces an equal volume of water, which has a weight of approximately 1 Newton. The block therefore seems to weigh about 1 Newton less. So, dyan nga sa example natin, meron tayong metal block. Pero nung nilagay na natin siya sa water is nabawasan yung 1 Newton. So, nabawasan yon. Kaya, yung metal block na nilagay natin is lumubog. So, meron tayo dyang buoyant force and the gravitational force of weight. So, let's proceed to the next. So, sinking and floating object. So, objects floats and sinks, and this buoyance and this is where the Archimedes principle begins. So, dun nga, 'di ba, kanina sinabi ko kanina nung na-discover ni Archimedes na nung pumunta siya sa tub, nagra-rise yung tubig. So doon niya na mas pinag-aralan na yung while the object was on the water, buoyancy occurs. So yun yung Archimedes principle. So we have here object floats and sink because of buoyant force or the upward force acting on an object. If the object is less than the weight of the object, it sinks. While if the density of the object is less than or equal to the density of a liquid, then it has the possibility to float on the surface of the liquid. So yun yung dahilan, 'di ba, pag nakikita natin may mga object na nagsisink. Meron ding mga object na lumulutang. So because of buoyancy. So yung mga nakikita niyo yung barko, 'di ba? Lumulutang sila. So dahil din 'yun sa buoyant force and the displaced water. So we have here sinking and floating object. So the reading of spring balance is 2.7 newtons. So volume of aluminum is 100 centimeter cube. The density of aluminum is 2.7 gravity centimeter cube. Mass of aluminum is 270 grams. Weight of aluminum is 2.7 newton. So, ito yung sa other side. So, dito naman tayo sa itong may tubig. So, volume of water displaced. So, yung volume of water na displaced is same dun sa volume ni aluminum. So, the density of water is 1 grams centimeter cube. Mass of water displaced is 100 grams. Same dun sa volume ng aluminum or yung weight ng object. So, weight of water displaced is 1 newton. So, the reading of spring balance is 1.7 N. So, dito naman, sa number 2, the volume of the wood is 100 centimeter, while the volume of water displaced is 60 centimeter cube. So, kaya siya lumutang. So, the density of the wood is 0.6 grams centimeter cube, while the density of water is 1.0 grams centimeter cube. The mass of the wood is 60 grams, while the mass of the water displaced is 60 grams. So, same lang yung water na displaced at yung mass ng wood. So, weight of the wood is 0.6 newton, while the weight of the water displaced is 0.6 newton also. So, what is the reading of the spring balance here if the wood is attached? So, yung spring balance na in-attach kanina is 0. So, ganun siya. So, the density and buoyancy from Archimedes principle. So, we have here the formula to get the buoyant force. So, buoyant force, it is the weight of fluid displaced or the upward force. So, we have here mass times gravity or density of fluid times volume times gravity. So, note, the buoyant force or upthrust is equals to mass times MA. So, note also, density of fluid equals mass over volume. So, dun nag-equal yung density. So, yung buoyant force is equals to density of fluid times volume times gravity. So, yung FB, yan yung buoyant force or upthrust. Yung density of fluid, yun yung parang P. And then V, volume of fluid displaced rather, or the volume of the object that immersed in fluid. So, buoyant force and flotation. Buoyant force affects the weight of an object. So, buoyant force equals weight. The object floats and is stationary. So, buoyant force is greater than weight. The object moves up. So, buoyant force is less than the weight, the object moves down. So, dito, pag yung buoyant force equal siya sa weight, the object floats and stationary. So, ano siya, lulutang or mag-stay. While the buoyant force is greater than the weight, dito na nagkakaroon tayo ng flotation or nagfo-float yung object. While the buoyant force is less than the weight, dito na nagsisink yung mga object. Kasi mas greater than si buoyant force kaysa kay weight. So next po tayo.